So here are some examples of 3D figures in which we can solve for either the surface area, that being the outside, or the volume of the shape. And so what we're going to start off with is finding the volume of a rectangular prism. So before we go on the sheet where we recorded all those lovely formulas, we need to pick which one we're going to use. And if we notice, the shape has a base at the top and a base at the bottom, and so you probably guess which one we're going to use. It is going to be big B times H, and this big B times H is going to give us the volume for this. Now remember, we have to realize what the big B stands for, and we can clearly see that on the top and on the bottom we both have a triangle, so we know we're going to be looking for the area of a triangle. And you probably recall there are two ways to write this. We'll just use base times the height divided by 2. Most times we write down a half of the base times the height, or vice versa. So what we're going to do to, of course, utilize this is the very first thing we need to do is find the B, the big B. So we're going to take this shape down here and determine which one is the height and which one is going to be the base. And if you remember, whenever we have something that's perpendicular, which we have, a right angle, we can then say that this can be utilized as our base and this as our height. Okay, so in our formula, we're just going to put right down here, first find A, which we know is the area of a triangle. We're going to take the base times the height, so we'll do 8 times 6, and then divide it by 2. Very simple here. Once we do that multiplication, we know we're going to end up with, of course, yes, 48 divided by 2, and then, of course, 48 divided by 2 is going to give us 24. So we now know, I'm sorry about this thing focusing like this. I'm gonna try to get it together. It might be too close to the camera. We're just gonna fill it into the formula. Let's see how we fare here. This seems to be okay. We know that the big B is going to be 24. We just found that. And we know the height is going to be 12. So to do this, we just put it into the calculator and we end up with 288. And we want to use the units. And in this particular figure, they give us the units of centimeters. So we're going to say that this is centimeters. And remember, when we are dealing with the volume, we're going to do the units in what we would call cubed, or to the third power. And that's it, just like that. So now we're going to move on to find the surface area. And the surface area is going to be a little bit different. There's some information we're going to need to find before we do anything. And yes, you guessed it, the very first thing we're going to do is solve for x. And in solving for x, what we're going to do is we're going to see first where x is located. Once we have located x, what I'm going to do is just cover up this top part right here so that you only see the bottom. And down here you can clearly see what has been formed. That is correct, a right triangle. So we can very easily solve for x by using our very favorite formula, a squared plus b squared equals c squared. C, of course, being our hypotenuse. Opposite the 90-degree angle is going to be our x, which is going to be our hypotenuse. Remember, your a and your b are interchangeable, so it doesn't matter which one you're going to use for a or for b. So let's go ahead and fill that in. I'm going to do 6 squared plus 8 squared equals c squared. And remember, your c squared is your x. Okay. When we do 6 times 6, we know that gives us our 36. And when we do 8 times 8, we get 64. And we know, of course, that's our c squared. Some quick addition here gives us 100. And of course, c squared. And then if we square root both sides, we're going to end up with our c equaling 10. So we know that x is going to be 10. Now, the reason that I'm playing it into the pictures because I don't want to get lost in the sauce. I need to remember what this is. So hopefully from the previous video, you remember that the surface area is just simply the area of the shape on the outside. So on this shape, we have 2 triangles. We have a triangle at the bottom and a triangle at the top. That's our base. What we also have is 3 different sized rectangles. Okay, so I'm going to walk you through this and let's see if you can come up with the correct answer at the end. So remember, the area is going to be for each shape. All right, so this is what we're going to do. I'm going to use this orange one to start off with one side. I need to know the area of this. Ooh, come on, highlighter. This one rectangle. Remember, the area of a rectangle is just taking those two and multiplying it together. Okay, so I'm going to write that down. 12 times 6. And that's one side, but that's not the only side I need. I need to also be able to get another side of this. So I'm going to add another side. Hopefully you're following. This side that I'm going to add is going to be located here. And again, this is another rectangle. So this time I have 6 times the height, and the height for here to here is also going to be 12. So I know this is 12. I know that this is also 12. I know that this here is going to be 12 as well. So I'll go ahead and mark those so that we have them. So we're going to have 12 times 8. And of course, there is one more that's located on the back side. And let me try my best to highlight that. Drop it down, drop it low, drop it low. Sorry. And here. So hopefully you can see that one that was in the back. I am so sorry about this. Doing that, I'm almost scared to touch it and mess it up. Okay, let me not tear up my stuff. Okay, anyway, so now that we are looking at the shape in the back, we see down here that it is 10, and up on the side we know that it is 12. So again, we're going to end up with 12, and then that's going to be multiplied by 10. Now that takes care of all 3 sides around this rectangular prism, but what is missing? If you said that we are missing the top, then you are right. You are exactly right. We are missing the top and the bottom. So we are missing our 2 bases. And when we think about that, what are the shapes of our 2 bases? They are indeed the triangles. So here what we're going to add is the area of the triangle, and that we already know. So what we're adding is going to be 2 times the area of the triangle. So remember, the area of the triangle was simply, and I'm going to fill this in, okay, is simply going to be our 8. Remember our 8 times our 6 and divide it by 2. Now you already know what number this is because we've already done the work. Okay? So for you to get your final answer, you're going to multiply, multiply, multiply 24 times 2, and then add all 4 of those together. When you're done, you need to make sure that your answer is going to be in centimeters and not the inside but the outside. So this is going to be centimeters squared. Okay, I would like for you to complete this, so when I check your notes, I'm going to be looking for the complete answer and that you have shown your work. Okay, and also don't be afraid of a big number. All right. Very good. Let us move on. Now, hopefully that gave you the opportunity to be able to work with both of the formulas. So we're going to go to the next one, and we're going to talk about finding a piece within the formula, not actually answering or getting the answer for the formula altogether. So I'm just going to slide that up. So number 2 says that a cone has a volume. So we already know what the volume is. We don't have to solve for it. So this is what it is. And we know that it has a height of 9. So we know that it is 9 centimeters tall. It is asking us to find PR, which is the slanted height. So we already know some things right away. You know, we got to work backwards, and in order to work backwards, we need to first work with what they gave us, and what they did give us was the volume. So what we need to do is put this and figure out which formula. So we go to our piece of paper and we look at our notes and we write down which formula we're going to use. Now before we get all happy about this, remember we've got to realize what that big B is, and we do know that that's going to be the area of a circle. And because it's the area of the circle, go ahead and write that formula down, because if we don't, we might do the wrong thing later. So the very first thing that we're going to do, I'm going to fill in this 9. I know that the height is 9. It tells me to solve for the radius, and I'm going to do just that. I'm going to solve for the radius. But how do I do that? Well, first let's remember our formula. Remember the formula for what they gave us is 1/3 BH. And remember, what was our B? Remember, we're replacing this for our B. So that's what we're going to do. I'm always starting off with the formula because we don't want to get lost in the sauce. Remember what our B is going to be. It is going to be pi r squared. And there's that H. So we're going to go ahead and fill everything in. I'm going to leave the units off so that there's no confusion when we get down to the end. So remember, what was B? 4, 3, 2, and what we cannot forget is the pi. Okay, so that's what we're filling in. Okay, we know that's going to be 1/3, and remember from your notes I told you I do not want you to convert these into decimals. You need to leave it as a fraction. And I'm going to go ahead and fill in the R. We don't know. And then of course our height is 9. They gave us that information. Now you can start working really in any order, whatever you want to get rid of first or combine. Now because we have this third and we have this lovely number of 9, we can easily know that 1/3 of 9 is simply going to be 3. And if that's what you said, you're absolutely right. Now we're doing that to just eliminate that. I'll go ahead and bring that down. Remember, all of this is multiplied, so we can multiply one step at a time. So I'm going to bring this down. And remember, we did 1/3 of 9, which gave us 3. And then what we're going to have right here is going to be pi. I'm going to go ahead and remove the parentheses. If you'd like to leave them, you can. Okay? All right, so now you can do one of two things. What I'm going to do is, I'm going to do this step by step, so it's up to you how you want to do it. You might be able to see right away what you can move, but I'm going to go ahead and get rid of the pi. Remember, we are trying to solve for the radius, meaning we need to get our r by itself. Okay, sorry. Cancel that out. Cancel that out. Then we know that 432 is just over there by itself. And we know we're bringing the 3 and the r squared over. We're getting closer, so we're going to go ahead and get rid of the 3. Now, you probably noticed that you could have done that in this step as well, and that's absolutely correct. But you know that I'm going to show the steps. So we'll bring this down as our 144, and that's going to equal r squared. Now, because this equals r squared, we, of course, do not have r by itself yet. So let's go ahead and do that. To get r by itself, we need to square root both sides. And of course that cancels out, and just like what it said we needed to do, we solve for r because we all know that this is 12. Now, because we know that the radius is 12, when we go to our picture, remember this is the center, circle O, and that our radius is going to be right here. So this is going to be 12. Now listen, y'all, this picture is not drawn to scale, and as you know, most of them are not. So don't get lost in this all saying, let's dig it in there. That's not what we're looking at right now, all right? Good. So the next thing we need to do is solve for PR. And you're probably thinking to yourself, well, I can do that. And you probably have already started. We know that this is going to make, and I'm just highlighting this if you choose not to, that's quite all right. That PR in which we are looking for is going to, of course, be our C in our favorite formula of the Pythagorean theorem, which we're going to have a squared plus b squared equals c squared. And C, of course, will be our PR. Okay? So remember, your A and your B are always interchangeable, so it does not matter which one goes where. So of course we know that this is going to be 81, and of course we remember from just a little while ago that that's 144, and we know that equals our c squared. When we combine these two together, we know that we're going to get the 225, and that will be equal to c squared. And then, of course, to get our c by itself, we hit it with that good square root to get rid of it. And then we know that the square root of this is simply going to be 15. So we know that this is going to be 15. Now, in the last two examples, you probably noticed something special about our triangles, or at least I hope you did it. I won't spoil it for anybody. So if you know what has happened, then you can tell me later. Okay. So we're going to move on to the last one that we have here. Now, the reason I wanted to do these particular examples is this is probably as hard as you're going to see them get. So I wanted you to be able to use the formulas and manipulate them a little bit for you to be able to use them. Now, for your homework, it's going to be pretty straightforward as far as they are going to tell you the shape, they're going to tell you what they want, and you have to pick the formula in which you need to use. So let's move on to this. So we know a hemisphere, we know that's exactly half of the sphere has a radius of 6. So that's the first piece of of information. They've given us a second piece in which a sphere, a totally separate one, has a radius of 3. And what they are asking us to do is compare the two. So we need to know which one of the formulas we are going to use. And remember, this is the only one that we have where the only piece of information we really need is the radius. So the formula in which we're going to use is V equals 4 over 3 pi r, and we know that this is going to be to the third power r cubed, whichever one you'd like to use. Okay, so this is the first thing I would like for you to do. Because we want to make sure we're comparing the two correctly, go ahead and first draw yourself a nice circle, and we're going to create a sphere. Now you might remember from your notes there was a circle there, and then I did these little dashes like so to kind of create the 3D look. Now y'all, don't be getting on my drawings. I know they bootleg. Okay, we're going to do that right there to represent the radius, and remember the radius of the sphere we had was 3, so we're just going to fill in 3 right here. And what we're going to do is get right to work. Go ahead and drop this into our formula so we can figure out what our value for this one is going to be. All right, so let's go ahead and do that. You know that I like to start off with the formula, and again, please do not change this into a decimal. The r that we're going to drop in, remember, is 3. Bringing this down, we're doing 3 times 3 times 3. So remember, 3 times 3 is of course going to give you 9, and then again times 3 is going to give you 27. All right. We're going to keep going. So what I'm going to do is just put an invisible 1 underneath here so that I can multiply these two. And because we're comparing, I'm going to leave this in terms of pi. So that 4 times the 27 is going to give me 108. All right, 108, and then of course the 3 times the 1 will give us 3, and what I cannot forget is my pi, and of course when we divide the 3 into the 108, we should get 36, and again we cannot forget our pi. Now it does not tell us units, so I'm just going to write next to it that this is units. And remember, when we are talking about 3D and what can hold on the inside, we want to be to the third power r cubed. Okay, all right, so now over here we're going to draw a half, a hemisphere over here. Okay, so remember they gave us this information, and I'm just going to do my best to draw this. So draw this kind of like a bowl. Okay, and again, y'all, the bootleg is real. So here we're going to have 6. And now that we have 6 here, what we're going to do is just fill this into our formula. So starting with the formula, we need to remember that this is not going to be the whole formula because we are only dealing with half. So at the end, I would ask that you go ahead and hit this with a half. Now please, again, leave this as a fraction, but because it comes out as a clean decimal, it really won't make a difference. But we don't want to get it confused with anything that's already in here. So we're going to bring this down, and this time our r is going to be 6. So remember, we're going to fill in our 6 here. And at the end, that's when we're going to hit it with that half, okay? So we're going to go ahead and keep working here. So remember, we're going to have 6 times 6, which is going to give us 36, and then we're going to do 36 times 6, and then that's going to give us our 216. So let's bring this down, 4 over 3 pi, and then 216, and then our half. Now remember what we're doing here. We're taking that 216 and we're going to put a 1 underneath it. And in doing so, it is going to give us 4 times the 216, which is going to be a really large number, 864, and then of course 3 times the 1, which will give us 3. And then remember, at the end we're talking about hitting that with a half, but not quite yet. We can do inside the parentheses first, which is going to bring that number down. So once we divide the 3 into there, we end up with it equaling 280. Look, y'all, you let me leave off my pi. I'm sorry, 288 pi, and we'll hit that with a half at the end. And then what we know is taking a half of this is that our B is going to be 144 pi. Remember, when we are discussing in units, again, we still, because this is 3D and we're talking about how much that half of a sphere can hold, we need to make sure that we also use the units cubed. Okay. So what essentially are we comparing? We're comparing the two. So we need to know how we are comparing them. Well, we can clearly see that one of them is larger than the other. So let's go with that for a comparison. So in doing so, how many times larger is one than the other? So when we look at the half of a sphere, we can see that it is actually 4 times larger than that of the sphere, and that is a good way to make a comparison and be done. And just like that, we have compared, because that's what it asked us to do. But we could not compare that until we actually came up with what the volume was for each one. All right, so these are your notes. Make sure that you put these into either your journal or whatever paper you are using and upload these. And make sure that you use your notes to help you with your homework.